In last class we studied about problems on Bessel function. In this class we study about orthogonal property of Bessel function. The statement is, if alpha and beta are two distinct roots of Jn of x equal to 0, means alpha and beta are two distinct roots, Jn of alpha equal to 0 and Jn of beta equal to 0. This is the these two are two distinct roots of Jn of x equal to 0. Then integration from 0 to 1 x Jn of alpha x Jn of beta x dx is equal to 0 if alpha is not equal to 0. Alpha is not equal to beta. If alpha is not equal to beta, then the value of this is 0. If alpha equal to beta, then the value of this integration is 1 by 2 Jn dash of alpha whole square. This is a statement. We have to prove this. We know that Jn of lambda x is a solution of the equation x square d square y by dx square plus x dy by dx plus lambda square x square minus n square whole into y equal to 0. We studied about this in the equation reducible to the Bessel differential equation. We studied about this in the equation reducible to the Bessel equation. If u equal to Jn of alpha x and v equal to Jn of beta x, if these two are Jn of alpha x equal to u and Jn of beta x equal to v, the associated differential equations are associated to these two. The differential equation are x square, this is u double dash plus x u dash plus here is lambda, here is if it is a lambda, then it is lambda square x square. If it is alpha, then alpha square x square minus n square. Here we take u, therefore u equal to 0. Take this as equation number 1. If we take v, then x square, this is v, y is a v, double differentiation v double dash plus x into v dash plus here we take beta, therefore beta square x square minus n square. In the place of y we take v, therefore v equal to 0. Take this as equation number 2. Then multiply the first equation by v by x, then second equation by u by x. Then we obtain x get cancelled, only remaining is x v u double dash plus x get cancelled, v into u dash plus alpha square one x can't get cancelled, another x is remaining here, u v minus n square u v by x equal to 0. Then again multiplying second equation by u by x, then we obtain this. Then subtracting these two equations, we obtain, taking common as x, the remaining terms are v u double dash minus u v double dash plus v u dash minus u v dash plus alpha square minus beta square u v x. This taking common as this, the remaining terms are alpha square minus beta square equal to 0. On subtracting these two equations, then we obtain this. See here, in these two terms are the derivation of this term x into v u dash minus u v dash. If we derive this, means differentiate this, then you obtain this u into v formula. First keep x as a constant, then differentiate this, we obtain this. Then this is a constant, differentiating x with respect to x, that is 1. Remaining these equal to, taking this side, then we obtain minus b square. It becomes plus b square minus alpha square into x u v. If we take this that side, then we obtain minus alpha square minus beta square u v x. Multiplying minus both, multiplying this minus inside, then we get minus alpha square plus beta square, that is beta square minus alpha square x u v. Then integrating these two, integrating both sides with respect to x from 0 to 1. Integrating this both side with respect to x between 0 to 1. Differentiation and integration get cancelled. That is taking over 0 to 1. That is x v into u dash minus u into v dash from x equal to 0 to 1 is equal to beta square minus alpha square is a constant because these two are the roots. And differentiating with respect to x. Therefore, integration from x equal to 0 to 1 x u v dx. Then applying these two limits. First apply upper limit with x equal to 0 to x equal to 1. If you put x equal to 1, then it becomes 1 u v dash minus u v u dash minus u v dash when x equal to 1 minus when x equal to 0 it is 0 equal to beta square minus alpha square x equal to integration from 0 to 1 x u v dx. Take this as equation number 3. Since we take u equal to jn of alpha x and v equal to jn of beta x, then differentiating this two, that is u dash jn of alpha x means alpha is a constant. Differentiating this, we get alpha is a constant, therefore alpha jn dash of alpha x. Same, v dash is means differentiation of this is v dash is equal to beta into jn dash of beta x. Put these values in this equation number 3, then we get v means jn of beta x. U dash is alpha into jn dash of alpha x minus u is jn of alpha x, v dash is beta into jn dash of beta x when x equal to 1 equal to beta square minus alpha square integration from 0 to 1 x u is jn of alpha x, v is jn of beta x dx. Next, first take this and taking this side beta square minus alpha square, taking this side, this is multiplied together, it becomes division 1 divided by beta square minus alpha square alpha into jn of beta x and jn dash of alpha x minus beta into jn of alpha x jn dash of beta x equal to integration from 0 to 1 x jn of alpha x and jn of beta x dx. Since alpha and beta are two distinct roots of jn of x equal to 0, means jn of alpha equal to 0 and jn of beta equal to 0. Here is there jn of alpha equal to 0 and jn of beta equal to 0 because these two are the roots of this equation. With the result, the RHS of 4 becomes 0. If you put jn of alpha equal to 0 and jn of beta equal to 0 in this equation, it becomes 0 when beta is not equal to alpha. Means beta square minus alpha square is not equal to, it will not become 0. If it is 0, then it becomes indeterminate form. Therefore, it is equal to 0. It is 0 when this is not equal to 0. Therefore, beta is not equal to alpha. If beta is not equal to alpha, then it is 0. That is integration from 0 to 1 x jn of alpha x jn of beta x dx equal to 0 when beta is not equal to alpha. When beta is not equal to alpha, integration of 0 to 1 x jn of alpha x jn of beta x dx equal to 0. We proved one condition. Next, we shall now discuss the case when alpha equal to beta. When alpha equal to beta, the RHS of equation 4 becomes indeterminate form. This is also 0 and this is also 0. 0 by 0. It is indeterminate form of the type 0 by 0 when alpha equal to beta. We shall evaluate by taking limits on both sides. We shall evaluate by taking by taking limits on both sides, keeping alpha is fixed by applying L'Hospital rule. First, take limits both sides as beta tends to alpha and keeping alpha is fixed. That is limit beta tends to alpha, integration from 0 to 1 x jn of alpha x jn of beta x dx equal to limit beta tends to alpha 1 divided by beta square minus alpha square into alpha into jn of beta jn dash of alpha minus beta into jn of alpha jn dash of beta. Applying limit both sides. Then alpha is fixed. Since alpha is fixed means it is a root of jn of x equal to 0. Therefore jn of alpha equal to 0. If jn of alpha equal to 0, then this equation becomes, this term becomes 0. Therefore the remaining terms are this only. Limit beta tends to alpha 1 divided by beta square minus alpha square alpha into jn of beta jn dash of alpha. This term becomes 0. Then applying L'Hospital rule. Applying L'Hospital rule means differentiate numerator and denominator separately. L'Hospital rule means differentiate numerator and denominator separately. Limit beta tends to alpha. In the numerator it has beta square minus alpha square. Alpha square is a constant because alpha is fixed. Keeping alpha is fixed means alpha is a constant. Only we have to differentiate beta square. Differentiation of beta square is 2 beta. Differentiation of alpha square is constant, it is 0. Then differentiating this. Alpha into jn of beta, it becomes jn dash of beta. Differentiation of this. Jn dash of alpha, it remains same because alpha is a constant. Next, now we have integration from 0 to 1 x jn. If we apply limits, beta tends to alpha means in the place of beta we have to substitute alpha. We have to write alpha in the place of beta. We have to write alpha. That is integration from 0 to 1 x jn of alpha x. Jn of alpha means, sorry, beta means it is alpha. Jn of alpha x, jn of alpha x, jn of alpha x, jn of alpha x whole square dx is equal to 1 divided by, in the place of beta we have to write alpha. Therefore 2 alpha jn dash of alpha is equal to jn dash of alpha jn dash of alpha square. That is integration from 0 to 1 x jn of alpha x whole square dx is equal to 1 by 2 alpha get cancelled, 1 by 2 jn dash of alpha square. If alpha equal to beta, this is the answer, and if alpha is not equal to beta, then this is the answer. Hence we proved orthogonal property of Bessel functions.